Ms. Whitaker, I'm kind of doing a few questions um, that are examples from your test review that you have for homework tonight. Please, please, please make sure you do it. It's worth 30%. Remember, we started in class, so you got a head start. And I answered questions in class as well. Please make sure your reference sheet is out in front of you and that you have your notes in front of you. You can use your notes to help you, but you must show your work. So remember, no work equals no grade. You will get it wrong if it requires work for you. So please make sure that you show your work. Okay, let's start with the first one. Number one, it was distributive property. I went over this in class, but I'll do it again just to kind of review. Remember that number that's always on the side. That is going to be the number that is on the outside of the parentheses that you are distributing. They have broken up this big rectangle into, they decomposed it into two parts. And they did that for you. So they might have maybe 5 here and maybe 7. So I just made those numbers up. They're not the numbers from your homework, but at least you have an example now. So in that first rectangle, you are doing 4 times 5. So you're distributing 4 and you're multiplying it times 5. Then in this box, you're going to do 4 again times 7. Remember, you're distributing that 4. That's why he's on the outside of the parentheses. So you're going to do 4 times 7. And then you add your answers together in the end. So this is what you should be writing as your answer on your prep work for number 1. Then they want you to evaluate it, which means they want you to work it out. So I actually distribute the 4, the 5, and I get 20. And then I distribute that 4, that 7, I would get 28. And so my final answer would be 48. So this is kind of what they want to see for question number 1 on your prep work tonight. Question number 2, 3, 4, 5, and 6 and 7 are area formulas. Remember, for each one, you must write the formula. So I love this example because this is the one that students tend to mess up a lot because it has this dotted line, and students seem to think that is a triangle. It's not. They're just demonstrating that is the height of the parallelogram. So they might say this is 5, and they might say the height is 8. Okay, so at this point, I'm looking at the whole entire shape, not the dotted line. What is this shape? It's a parallelogram. So I go to my handy dandy reference sheet and I write down that formula, which would be the area is base times height. The base is equal to 8. The height, they show with that dotted line, is 5. And so I work that out and I get 40. So the answer would be 40 units squared. So just don't let that dotted line trick you to think that you have to cut the shape in half, because the whole shape is not a triangle. That dotted line makes it look like you see a triangle. It's just showing you the height. But do remember, if you see a triangle, that you are to cut it in half. The formula for a triangle is 1/2 base times height. So I know some of you are struggling when, like, the bottom might be 7, the base, and the height might be, let's say, 3. And some of you know you're supposed to multiply them, and you say 7 times 3, but you know you have to cut it in half. And you're looking to see which number can I cut in half. Well, they're not even, so you can't cut them in half. So what I recommend you do is I recommend that you actually multiply the 7 and a 3, and you get 21. Now I've got to cut 21 in half. Again, some of you are struggling at this point. I would say, okay, let's write what is the one number above 21. It's 22. What is one number below 21? It's 20. Then you can say to yourself, well, what's half of 22? That would equal 11. What's half of 20? It is 10. So 21 should be somewhere in between your 10 and 11. If you think of it as money, what would be exactly between $10 and $11? It would be $10.50 or 10.5. So that might be a strategy that can help you cut those odd numbers in half. Trapezoids, that's another one. Don't forget the formula for that is just like a triangle, except for, because it has that 1/2, you have 2 bases you have to add before you do anything. So if I have a shape, and remember, this is a trapezoid also. It doesn't look completely like one. It's called a right trapezoid, okay? And if I give you this base of being maybe 4 and this being 6, and they might show you that the height is, let's just say 7. So I would write in my numbers, filling them in. This 4 would be a base. This 6 would be a base. I have to add those numbers together because I have to add my 2 bases together. And then my height was 7. You cannot cut anything in half at this point until you add your bases together. So I add my bases together and I get 10, and 7 is my height. So I can either multiply them and then cut in half, or if one of my numbers is even, I can cut it in half ahead of time. So I cut my 10 in half, I get 5, and now I have 5 times 7, which would equal 35 units squared. So that would be the area of this trapezoid. I know, sorry, kind of cut it off right there, so I zoomed in so you could see the answer. But that is how you work that out. Going to the next section, which was asking you, oh, there was a kite. I forgot that one. There was a kite, and remember, a kite can be cut, and it makes 2 congruent triangles, which we know a triangle is 1/2 base times height. But if you're doubling it, you really don't have to cut it in half. It becomes more like a parallelogram. So we talked about this in class quite a bit, and we said that we could use the formula for a parallelogram, which would be base times height. But you need to be careful because you need to use the whole middle from the 2 further outer tips here and here. This is going to be your base, the whole thing. Okay, your height now is not the whole height. It's from the base straight up to the very top. So this is your height. Again, this is your base, the whole thing. Okay. Sometimes I notice they break it up into sections, so they might give you a number for the base from here to here, and then from here to here, and you have to add the 2 together. So let's pretend that they said, let's call this, get a different color. Let's call this A. We'll call the middle point here B and C. So they might say from A to B is equal to 6, and they might say from B to C is equal to 8. So you would need to add those 2 parts together. So again, from A to B, which is from here to here, is 6, and from B to C was 8. So you need to add the 2 numbers together to get the whole entire base. So we would say my base is 14, and then my height, again, sometimes they'll refer to letters, and let's say they say up here is E. Then you'll look for E to B, and let's say they say that is 5. So you know from E to B is 5, that is your height. So you plug in 5, and now you work it out as 14 times 5, which would be 70. So 70 units squared. I don't have to cut anything in half because I treated it as if it was a parallelogram. And the bottom flipped up and met the top, and it made a parallelogram. All right, going on. Number 11 and 12, part A, I did those answers for you. I described 2 different strategies that you could use. And both of them, I said you could find the area of the entire shape. So you could find the area of the whole thing, and then find the area of the non-shaded parts. and then subtract it from the whole entire square. So it does take a lot of work. Or you may want to think it's easier to do the second strategy, which is just find the area of the shaded parts, the triangle here, and the triangle here, and the triangle here, and then add your 3 areas together. So again, you could use this strategy, which is find the area of the whole thing, subtract out the white parts, the white areas, and whatever is left would be the shaded part. That was strategy 1. And strategy 2 was where you just find the area of each shaded triangle and then add them. So whatever you think is easier for you. I will tell you on number 11, that is a square. So if this side is 65, then this whole side right here is 65. This whole side here is 65. This whole side here is 65. If you only need to know half, like from here to here, you have to figure out what is half of 65.
King George to the front office, please.
Okay, you got to hear the intercom because I'm doing this during my planning time to save some time. Question number 12 is just like number 11. If you go to the back side, number 10, again, you have to use, you have to find the area of part, or the length of part A. Says you got to find the length of part A. Then you got to find the length of B. And the reason why they're having you do that, because it's going to help you with part B. Okay, so you really need to look around, because I noticed part A, this was A. They give you a number here, which is 15. They give you this is 15. And then down below, I think this was the children's pool. This is a driving area. And this was the recreation area. And if you look at the bottom, this is 25. So you should be able to find out what A is, because you know the whole thing. Because if this is 25, this is 25. And so to figure out that missing part, you got to take the whole thing, subtract out 15. Whatever's left should be A. And you would do the same thing to figure out the length for B. So part A, I would say, is 10. I'm giving you a freebie right there. So if you are watching, kudos to you. Because if you plug that in, 10 plus 15 is 25. Now I'm going to make you find out what B is. I didn't draw the whole picture out because I ran out of room here. But part B says now they want to know the area for the pool and the driving area. So you got to find this little area here and the pool. You find the area of both and you add them together. So you do the area of the pool plus the area of the driving area. And you add those two answers together. And that would be part B. Now part C is, now you got to do another little bit of work. They're saying each square foot is, or square meter is $17.50. So you got to take that $17.50 and you're going to multiply it by your answer you get for part B. Now remember, you have 2 decimals, so you're going to take it out 2, and you're going to make sure you remember to bring in your answer the decimal back in 2 places. Oops. I don't think you can see it. Okay, I help a little bit. Going to the next part, Oh, number 15. This one, they're giving you a problem. I'm going to make up a different number. I might do like 24 plus 16. And they're asking you to use distributive property, this format, where you have the parentheses, by using, you're going to pull out a common factor of both these guys. Well, I told you in class you cannot do 1. You could choose to do 2. I know 2 can go into both those numbers. I know 4 can go into both those numbers. So either one of these would work if this was the problem. But I did not pick the same problem from your paper. 2.
Pardon the interruption, teachers. Please don't forget your attendance sheets. Thank you.
2 can go to 24 12 times. So 2 times 12 would give me that 24. And then 2 times what gives me that 16? It would be 8. So this would be a possibility to put down for an answer. Or if I chose to pull out 4 as a common factor, I would say 4 times what gives me that 24? 6. And I'd say 4 times what gives me that 16, which would be 4. So either one of these answers would be correct. So you're going to notice in 15 and 16 that you can have more than one answer. I think in 16 there's only going to be one, though. I'm looking at 35 and 42. I think there's only going to be one answer. You should know how to do 17 and 18, finding common multiple or common factors, and 18 is finding common multiples. But you have to go between, you can't do any higher than 100. So again, I think factors, again, you're finding the numbers that equal 16. Talking about number 17 right now. And you're finding numbers that equal 64. And then you're circling those common ones. You're circling those common ones. So for like 16, you do 1 and 16, 2 and 8, and 4 times 4. But you only really need to write 4 one time. Then you come up with all the things that equal 64, like 1 and 64, and so on. And then you find the ones that are the same. And 18, you got to find the common multiples. So it's kind of like you're counting by these numbers of 3 and 11. And you got to find the ones that are the same, but you don't go past 100. So I would count by 3 and say 3, 6, 9, 12, and so on. And you do the same thing for 11. So that'd be 22, 33. Oh, I have a feeling I'm going to have a common multiple here with 33, because I think as I keep going with 3, I'm going to eventually get to 33. But there might be more because you got to go all the way to 100. 19, prime factorization. That is the prime tree, where you have 280, and you get a list of things that equal 280 until you get prime numbers. So for me, I would definitely say, since I have the 0 in the back, I would say 10 times 28, and then break it down more until you have circled all your prime numbers. 20 is the same thing. Determine the least common multiple of each set of numbers. Now I'm on 21. Remember, for this, I gave you the formula. It's always the product of the two numbers divided by the greatest common factor. It will equal the least common multiple. So they gave you 4 and 6. Well, I know the product of these two numbers would be 24. What would be the greatest common factor of these numbers? Well, I know that 2 goes into both of them, and that's going to be the greatest common factor. So I divide it by 2, so it should equal 12. That should be my least common multiple for those two numbers, 4 and 6. So that was an easy one because they were small numbers, way different from your prep work that we created last night from you had over the weekend. The next one, Derek wrote 8, 9, 12, and 15 on the whiteboard. Which pairs of these numbers are relatively prime? What they mean by this one is when you write 8 and you break it down and you can do 2 and 4, only one of your pairs is prime. You need to find out which number or numbers that when you break it down, for example, 21 would be an example that you would write 21 down if it was listed, because both numbers, when you break it down, are immediately prime. So 21 would be an example of what they're asking if they say relatively prime. They want both factors, when you break it down, to be prime from the start. 25, 26, and 27, they want you to find the greatest common factor doing the factorization tree. So for like 25, they did 8 and 50. Well, 8 can be broken down to 2 and 4, and 4 can be broken down to 2 and 2. 50 can be broken down to 5 and 10, and then 2 and 5. What numbers do they share? Where they both share a 2, and that's it. This side has 2's, but this side does not. This side has 5's, but this side does not. So in this case, 2 is the greatest common factor. Now remember, if I happen to have had a 5 over here on this side, then I could have written down 2 times 5, and then 10 would have been my greatest common factor, because I would have had 2 2's from or a 2 from each side, and I would have had a 5 from each side. And that's all. That's all you have for prep work tonight. I did an example from every type. Good luck. Make sure that you show your work so we can give you full credit. And remember, this is worth 30%. Use your notes. You can phone a friend, but make sure again you show your work. And you can use an older sibling, parents to help you if needed be, or myself. But I want you to try your best on your own, because Wednesday is your test. We'll be reviewing, going over the answers tomorrow, and I think I'm going to make a study guide for you to study along with your test review. So good luck. See you guys tomorrow with your homework done. Everybody. Bye-bye.